My name is Jess Larson, and I am meshIQ's events manager. I would like to welcome everyone attending as we really appreciate you taking the time to join us. In case you don't know, we present monthly webinars on different middleware technology topics that are part of our Tech Talk series, and today is the 9th Tech Talk this year. At the end of this presentation, I will include links to watch past Tech Talks on demand in case you missed any of the previous webinars. So today's topic is modernizing real-time observability for event-driven hybrid IT architectures. Feel free to send any questions you have throughout the presentation in the chat box for the Q&A portion at the end of the webinar. Before we start, I'd like to introduce our two wonderful speakers today. So Albert Mavashev is meshIQ CTO, who turns ideas into real-world solutions. Our other speaker today is Jason English, partner and principal analyst at Intellex. Drawing on expertise in designing, marketing, and selling enterprise software and services, he's focused on covering how agile collaboration between customers, partners, and employees accelerates innovation. I will pass it over to you guys to get started.
Great. Thanks, Jess. Jason English here. How's my audio? Does it sound pretty good?
Yeah, it's good.
Good. Basically, we're really here to talk about event-driven architectures. So the introduction of open source Kafka in 2011 created an ideal scalable data platform for applications. And streaming data is ideal for EDAs, and that's especially relevant as a scalable source of state for stateless ephemeral microservices that's orchestrated by Kubernetes in conjunction with integration platforms, service meshes, and other types of integration work. Fortunately, EDA has a data-centric design that allows analytics functionality and data to scale faster, especially in complex multi-party environments, as consumers and producers of topic data can be added with minimal impact on the existing workload. So whether it's perfectly suited for highly scalable, complex analytics, whether for supply chains or financial analysis or system performance metrics, security, all kinds of very high data intensive applications. Data scientists also use real-time data analytics to train and augment machine learning capabilities. These events are often first recorded in the application systems of record and cloud data warehouses. And then the EDA detects changes within those core systems. That comes with the territory, as well as accepting messages from other services and producers. So the whole goal really is to make the organization more responsive and agile. Jess, if you want to put on that first slide. So Albert, it's great being able to join you on this Tech Talk today. What, in your impression, is driving interest in EDA today?
Thanks, Jay. Thanks, Jessica. Happy to be here. EDA, it's interesting. I feel if you look at kind of the history of the EDA, before it was called kind of application integration, and there's just a variety of different ways people refer to it. So it's not like anything new necessarily. People have been doing this for quite some time now. Before, there maybe weren't as many technologies available to connect things together. But today, you actually look at the landscape, it's fairly rich. You've got hardware-based integration, you've got software-based, and they all mesh together in a variety of different interesting ways. I think what's driving it is this whole area of digital transformation. People, and especially depending on what you're looking at, like if you look at large organizations, well, they have investments in legacy apps. So for them, it's all about bringing that and integrating with the cloud and with their customers and connecting with their mobile, where the customers are. And today, mostly they're in the mobile devices. So that's driving a lot of that. And then for new companies, it's all cloud first, and they're born and develop in the cloud. And for them, it's all bringing the data from a variety of different other data sources. So regardless of what, whether you're large, small, or software company or banking or whatever, it's driving because competitive pressures, being agile and providing real time, it becomes key. And in order to do that, you have to connect things together. So that's, in my view, is kind of what's driving EDA, and it's not doesn't look like it's gonna stop anytime soon.
Yep. Great. Jess, next slide. So, what is an EDA? Right. For this one, I've basically just shown some pictures that I grabbed from the Apache Kafka off the Confluence side. I really like their little cartoons they do. Just like Albert was saying, it's interesting how on one level it really doesn't look like we've changed much since the days of middleware or three-tier architecture. And event-driven architectures actually have been with us for some time, ever since there were message queues or pub/sub topics. Wherever you have upstream and downstream services and there's a middleware integration pipe, it could have been good old MQ services or JMS, or it could have been an ESB or later some form of service mesh or integration hub. But what's really different is perhaps how the objects on either side of this integration layer behave, right? The producers and consumers and how they interact with the EDA event layer. That's what's really different about using a system like Kafka as that pipe. So we're going to talk about that in this webinar. We'll talk about Kafka. There's a lot of other ways to be event driven. So it could be using Solace or RabbitMQ or a number of other things. But really, the other aspect of this is we used to talk about this strictly in terms of when we talked event driven. We used to talk about those as being asynchronous environments, where the data exchange is asynchronous as opposed to asynchronous, like a RESTful or HTTP style interaction. But now EDA really includes both of those types. So Albert, what's your kind of impression of how this fits in with your history and where it's going?
I mean, yes. I mean, before it used to be all, a lot of, the three-tier standard synchronous. And I think a lot of the event-driven was kind of brought about by this need to do things in an asynchronous fashion. So then the messaging came, and it used to be called, messaging paradigms, and today they're called event-driven. I mean, but in reality, it's just messages triggering different business logic across. And I would look at, they're all really accomplishing kind of similar concepts, in that you could build this type of asynchronous event-driven or message-driven apps. And obviously you design them differently, whereas before it was you receive the message and you perform business logic. Today it's everybody's run on their own cycle, on their own time, and then you receive a message or an event and you do something about it. And then these different technologies, like you mentioned, like Kafka, MQ, Solace, or GMS, and others, they all accomplishing very kind of similar things in a sense, but they all have their own kind of details as to what they're good at. Like really, like Kafka is really all about like high performance, pub/sub in a sense, right? Whereas like messaging or standard like MQ, GMS, they're all about, queuing and ability to, first in, first out. But essentially you build similar types of architectures. It's just like, for example, for high speed small messages, Kafka would probably be really a good idea, or for example, even Solace would be a really good approach. So you would see for high performance event-driven architectures, they would put Kafka or Solace or something like that. And then more for resiliency and then transactional, they would, organizations would select, let's say, IBM MQ running on a mainframe. And then you have to connect all these things together. And that's what I would call it, a mesh. And that's what makes this kind of field, I would say, this space is very exciting, because not only there's just a lot of innovation happening, but there's also just a lot of different technologies connected together.
Yep. Yeah, very much agree with that. Jess, next slide. So we're going to get into the topic of observability. What really is observability in this context? I mean, obviously you have your four classic golden signals of errors, saturation, traffic, latency, and stuff like that you're monitoring within the system. But in Telex, we always think of it as watching everything that's happening within a complex, interconnected, distributed system. So that depends a lot on getting telemetry from all of the components that are deployed in the field there. So this telemetry is emanating from so many constantly changing configurations of microservices that have to coexist along with our internal systems behind the scenes. So we really want to make sure that it is fail-safe, but also doesn't limit our decisions later as far as building new functionality atop this or changing the workflows and the workloads that are launched by our system. So, Albert, what's your impression about how observability happens at all these different layers of an event-driven architecture?
Yeah, so observability is an interesting kind of topic because actually it's being overloaded and redefined in many different ways. I mean, before they used to call it monitoring, now it's observability. And the way I look at it is I look at observability as two pieces. One is ability to collect metrics, and which really puts an emphasis on instrumentation itself, meaning if you look at the different, let's just say Kafka, Solace, and whatever, in order to monitor things, they have to be able to export all the relevant metrics and all the relevant like logs, traces, and metrics. If the underlying infrastructure does not expose this, you can't really monitor it effectively. So think of it as two parts. One is being able to expose the underlying metrics, logs, and traces. And then the other side to make sense of it, be able to collect it, be able to store it, and then make sense of all of this. I think what complicates this whole area significantly is because it's so vendor focused. Like, for example, Solace will have its own set of metrics, and then Kafka is going to have its own set of metrics.
Mm-hmm.
And then in the perfect world, it'd be great if everybody would be just doing same thing and doing in the same exact fashion. But in the real world, what happens is now you're stuck with metrics, logs, and traces coming in from different kinds of technologies, and they're all driven by their own vendor implementations. And the burden is really put on the organization to figure out what to do with all this, because latency is measured differently, the kinds of metrics they put out is different, and the kind of automations and interfaces are different, and management interfaces are different. So it's if you just the whole world would be Kafka or GMS or let's say RabbitMQ, the world would be, you could all do it one way and it'd be easy. But unfortunately, that's not the case. So observability becomes a real problem because of that. And there are some ways that the industry is trying to address it, like open telemetry, for example, and the pushing of open telemetry standards and adoption. But the adoption is kind of slow, and there's just a lot of vendor specific things that go into it. So observability becomes a real challenge in my view, especially when you look at very kind of hybrid environments.
Yeah, I think a lot of people, there's a lot of promise in the open telemetry movement as part of the overall cloud native development movement too, and it's very productive, but it does require learning a lot, I think, for end customers to go down this route. So let's go ahead and, go ahead.
Yeah, exactly. And then, when you look at even open telemetry, I mean, if you even look at this diagram, I mean, in order to really manage it, and we see organizations like, for example, our customers, I mean, they at least have at least 2 or 3. So, and then once you connect cloud, then you're dealing with cloud providers, or whether it's AWS. So now you've got different Kafka flavors. Now you've got like Amazon MSK, and then you've got Azure ESB. I mean, it's just all over the place. And then each application group decides on their own stack, and you have to connect things together. How do you observe that? Well, you almost need you kind of need to start from scratch. You need to develop, well, what are the common metrics? Where do you store it? How do you do it in a consistent fashion? How do you apply different algorithms? And how do you track the flows across? And open telemetry helps, but the adoption isn't there fully. So organizations have to kind of figure out, while the industry is maturing, what do you do in the meantime? You still have to run the business, and you still have to keep the lights on. So that's I think I would say is a big challenge here.
Yeah, definitely. Jess, next slide. Yeah, so which leads us to ask basically, what constitutes real time, really? I mean, it looks more like sort of more like a space station than a directly connected environment, right? You have events bubbling up from all these different types of inputs, whether they're coming from outside services, whether they're coming from core systems, or from other applications and services, or feeds coming from other news sources or data sources. All of these kind of bubble up through this layer and become part of the question. It's kind of interesting. I think I originally had developed this graphic to describe blockchain, but it's really not like that. But in a sense, if you were to have an append-only database instead of an event-driven database, you would kind of see that you could kind of see how you'd subscribe to something and add to it in this sort of way, right? As new data comes in, you're basically subscribing to what happens and then recording that as a system of state. So that's kind of how we've built it out from here. The main need here was really a sense of the mission critical nature of our applications and the need to be able to scale gracefully over time. That's really, once the idea of big data and Hadoop fell down, Kafka became a very popular alternative after that. And so that kind of describes how we see this. And what's your impression of, what constitutes real time to you, Albert?
So real time, obviously, if you look at the tech, almost like, if you really become really scientific about it, I would say most technologies fall real short of real time, because there's this latency gap between when you observe to when you actually make a decision or even understand what's actually happening. So on one side, you consider two parts of it. One is, what does real time mean in observability, meaning from the point of of observing something to the point where you can make a decision. And the other side of the event-driven architectures is, how well does it actually drive real-time applications? And it all comes down to latency. That's why I think Kafka is such a took off, is because a lot of the messaging platforms, while they would focus on reliability, because there's aspect of reliability where you sent a message, you want to make sure it's guaranteed delivery. And this is like, for example, like originally why IBM was so great, is because it was focused on this transactional reliability. And then Kafka and other technologies comes along and they kind of say, you know what, let's not worry about reliability that much, even though today reliability is becoming an issue. But let's focus more on this whole real time and then performance aspect. And now, if you really want to deliver, millions and hundreds of millions of events per second, you need to go to this new level of integration infrastructure like Kafka, Solace, and things like that. And now they do have actually good, fairly decent guaranteed delivery as well. So I see it as this whole concept of latency, how well they can drive and how quickly they can deliver data across. And a lot of these new technologies actually do a pretty good job. Now, they usually go into the, I would say, microsecond, millisecond range. I think few go into the nanosecond range. I've looked at, there's some technologies where, especially you deal with algo trading, that's when they really squeeze the most of the latency and you get down to the nanosecond range. But in most environments, we see it's typically in the microsecond, millisecond range is where they would be considered a fairly good level of performance. But you have these other, like you mentioned, blockchain. Most blockchains are much slower. I mean,
Oh yeah.
they're like, like, for example, Bitcoin would be 10-minute block, and then Ethereum like I don't know, 10 seconds or whatever. So they're not nowhere near what current infrastructures need to deliver. But you have a choice of all this technology. It just depends on what your application needs, and then you decide which stack you want to build on.
Yeah, that's definitely true. there's not going to be any scaling of that for distributed ledgers like that for quite a while. But I think the idea really was this idea of a kind of shared event space, and I think that's an interesting angle to it. Let's go ahead and move on to our Q&As and kind of get into the discussion a little bit more. So Albert, I mean, how did meshIQ evolve from one of the kind of original integration and management vendors that you kind of started out as a member of Nastel and working alongside you in the early 2000s as well, to being a real-time observability vendor? I mean, how does that indicate how the space has really changed for you and for the rest of the industry?
Yeah, so I mean, when we started, I mean, messaging was really in its like early stages, right? There wasn't even like these proliferation of these messaging platforms. I remember one of my first things I was doing was actually coding an SNA LU62 protocols and early TCP/IP. I mean, that's how people connected things together. So the problem was always there. They just solved it in using different ways, and then they came up with different abstraction layers, and then there was IBM/MQ, and then there's other GMS protocols started to evolve, and now look at the space today. It's got so many different variety of different integration and messaging technologies. But when we got involved with especially like large organizations, for us it was always listening to what our customers are doing and kind of what they're doing and what they're building. And then we always saw the push for this real time, meaning we want, if it was seconds, we want milliseconds. If it's milliseconds, we want microseconds. And you could see it in the application release cycles. Before, they were very long. Now everybody's shortening the release cycles. So it was always about, can we collect information very, very fast? Can we make sense of it? And then can we automate? Can we take action? Because as you know, today, most of the activities, in fact, are driven by automation. And one of the things that I haven't mentioned before, especially when we talk about integration space, automation is a big factor. Meaning when you manage these deployments, meaning how do you automate workloads and stuff like that. So for us, it was a journey with our customers, meaning listening and then enhancing our platform. And we went through a variety of different innovation cycles, where we went from simply managing MQ to managing multiple middleware to broadening the scope to different telemetry. And today, we look at a space where tracking transactions and tracking individual messages at high rates becomes a reality. So for example, when you look at the mesh and you're processing billions, in many cases, of messages a day, and if somebody calls you up and says, hey, we didn't get this message, what happened to it? How do you solve that problem? It's like looking for a needle in a haystack. And we've always wanted to be able to solve difficult problems and do it in a very efficient way. So hence the technology has always been kind of like, hey, let's take a step forward and solve the most difficult problem. And that's what took us through our journey of going from a simply management of MQ to today an observability platform for the whole mesh.
Yeah, I think it's a really interesting story of evolution. I mean, in the sense you had to eat your own dog food in order to kind of like pick your own systems up to get them up to this level, right? You have a different way of looking at a mesh that, we have a traditional definition of service mesh, but you have your own definition of mesh, which is kind of interesting. So how does that affect the observability for your customers in the end?
Well, yes, and I think the industry's view of observability is, I think, in my view, is fairly narrow. I mean, it's observe, and they very defined like log traces, and then you make sense of it. We look at observability almost like observability plus. Now, for us, observability means not just to observe, because the next logical step becomes, well, what do you do once you know that there is a problem? Once you know, or let's say you're figuring out that you're predicting, let's just say anomaly detection today is a very common thing that observability technologies do, then the next step obviously comes to action. You have to now do something, whether that's configure, whether that's automate, whether that's deploy. So we're looking at this whole thing as a 360-degree cycle, meaning observe, act. It's not
Mm-hmm.
just, it's the governance side, it's observability side, it's automation side, it's intelligence, and they all need to connect together. I think in the mesh, especially if they're not connected, then what happens is you just have a lot of silos and then a lot of breakages in between. And then what happens is I think the vendors are then have to, well, not the vendors, but the organizations are kind of stuck with integrating this whole thing together, because how else are you going to do it? So we're looking at this whole cycle in the sense that observability, yes, it's important, but it's not enough in order to manage the mesh in the appropriate fashion. And you need automation, governance, intelligence, and observability connected together and hooked together.
Well, how is observability different for Kafka clusters than for the rest of the distributed software architecture? It seems like there might be different measures for scalability and resiliency than we'd have for other types of service-based systems or REST style integrations. So, and even earlier styles of EDAs.
I mean, I think in general, they're not much different. I think what is different is that, it's always like devil is in the detail, I would say.
Mm-hmm.
Kafka has its own details of how it deals with clusters, how it load balances itself, and how do you do automations, and how do you, partitions and topics and things like that. So I think the devil is always gets into the detail, while in general, you approach things in the same way. But then once you get down to detail, that's when it's different. So for example, when you deal with GMS based implementation versus MQ versus Solace, yes, they have different, very similar concepts and approach things in the same way. But then implementations are different. The way automations are different. The APIs are different.
Mm-hmm.
And that's where it creates a lot of complexity, because now you have to deal with all of these details of how you do things, and each technology introduces you know, its own level of detail. And I think that's what complicates things a lot. There again, we talked about like open telemetry is trying to abstract some of these things away, but it addresses a very small part of the overall problem. So yes, it can do certain things and it can help with certain things, but it doesn't. And it also introduces other challenges as well. Like we haven't talked about like context propagation and things like that. That introduces a whole new set of challenges, and then somebody has to deal with this complexity at some point.
Mm-hmm. Yeah, that is a big one. The other one is really, once you start opening up your lens to get observability into these systems, what do you do with this flood of incoming event-based data? I mean, some companies try to take care of it at the head end with by sorting topics out of the stream before they enter some other kind of data warehouse, and some try to do it in the middle with some sort of filtering, and some try to do it on the back end where they just try to dump everything into a warehouse and then figure it out
Right.
later, which is a little bit slower. But what's your opinion of what enterprises can do to address all of this data that comes
I think
from a live system?
I think a lot depends on how much money you have, and how much, like we've seen some that go with the brute force approach, which basically means store everything, analyze everything. And it's, let's collect every piece of information we can possibly collect, store it in some kind of data lake,
Yep.
and then let's run some ML algos, jobs on top of it to figure things out. I mean, we've seen that approach, and that's why you've got some companies, investing in like Splunk and others, and it's a very expensive proposition. Now, what I've seen is a lot of this data is mostly useless. You store lots of data,
Yeah.
you get very little return on that. So then we've seen obviously where you try to filter and you try to be smart about it. One of my talks before, I was talking about like smart telemetry, where you apply ML at the collection layer. So you can decide as to what are the right things you want to collect at what times, because it's also very time dependent. Some things are you need to collect at this point and maybe not at other points? How do you make all these decisions? And I think ML and AI can help in these regards, where you don't necessarily need to collect everything. You collect the right things at the right time for the right set of problems. But I think most of the ways, what I see for most organizations, especially large, they just happen to collect because maybe at some point they need that piece of data and then they come back to it and they dig it up. But they need to maintain large data lakes, and it's fairly expensive to do.
Yeah, I mean, it's generally good advice to say, better be safe than sorry, I guess. But there's definitely a lot of unexpected or surprising costs that can emerge from taking this approach.
I think that's where
Yeah.
I think that's where observability technologists can help, because that's, I think, where technology and innovation can really drive, because it's not just about making sense of the data, but how do you decide even what data to collect, when to collect, and in what resolution and what amounts to collect, because that can help overall total cost of ownership for the organizations.
Yeah, definitely. But let's talk about just hybrid IT in general. We always say hybrid IT instead of hybrid cloud, and it seems like it fits really well with meshIQ's definition of it as well. I mean, because it encompasses many other upstream and downstream vendors and services in a very heterogeneous landscape. It's not just about using multiple clouds or a mixture of cloud and on-prem. It's really a little bit bigger than that, I think. How do you see the concept of real-time observability fitting into this hybrid IT environment?
Well, I mean, to me, I look at it as yes, you've got the hybrid IT where it's on-prem, cloud, and all hooked up together. But at the end of the day, that's more of a complexity that maybe most organizations would maybe rather not deal with. It's just they're driven by lots of different reasons to go that route. So the idea is, how do you abstract it in such a way that hybrid IT almost looks the same, whether that's cloud or not? I mean, and a lot of it is really now focused on how do you simplify this approach, because it's not just that. You've got containerization, you've got virtualization, you've got on-prem, you've got Docker. I mean, there's just so many moving parts, and dynamic workloads and workloads moving from on-prem to cloud and then from different cloud, and then you've got security. I mean, I feel like it's just so much complexity that I think the job of observability is to simplify this. And I think a lot of it is, hey, we make a step in one direction to simplify something, like, for example, even with cloud, one of the reasons was to simplify things. But introduction of it also complicated a bunch of things. So we almost, like in a zigzag situation, we simplify, and some of the simplification drives more complexity. And then part of the technology is now, let's take it and figure out how do we simplify this whole environment. So observability, in my view, one of the major tasks of observability is to actually make things simple, not just to detect a problem, but how do you make things simple? Because you need less people. If things are simple, you need less people, less time, you need less skills, and skills, as we know today, are difficult to come by. So I think it's a big part of ease of use is simplification.
Yeah, it's really our expectations of the system, and a lot of the simplification comes through, it's a better interface and more visibility and things like that. But a lot of it has to do with how well you abstract all of these complex layers into one view, and a lot of it really has to do with reducing it back to what are the actual customer requirements of this, and how do I set all of my policies so that these things are automatically alerting me or happening in order to meet these customer requirements. And that's really what it all boils down to in the end.
Right. And in observability, what's interesting is, like, for example, topology views becomes really important because, I mean, essentially, what's a mesh? It's really kind of a highway system in a sense. You got different pipes hooked up together across different set of infrastructures. I mean, you got to be, it's like a subway map in a sense, right? So you got to be able to visualize and know what's moving, where the latencies are. So topology views becomes very critical. But then there's the other side of this. How many people do really want to be looking at a screen at all? So then the other side is what do you do in the background that really doesn't need anybody to even look at the screens at all? So you've got automated anomaly detection, ML algos that figure things out and then automatically take action so that you don't even need a human to even click or do anything. So a lot of it is also part of observability is really focused on automating things and taking action. So, and that's how we look at that stack. It's not just, making sense of things, but also what actions can we take to automate this environment.
Yeah, exactly. And it seems like maybe 5 years ago or so, we started having this impression of an SRE comes into the environment. They basically are like an all-knowing superpower person who can dig
Right.
into all these details and go uproot issues wherever they might exist in this complex stack. And that's definitely not scalable. It's the opposite of where we need it to be. And so I thought it was kind of interesting that we could end up back at this point again. But here we are. Just a greater need to make it easier for the rest of us.
Right. And then definitely because there's also, like, for example, when we talk about hybrid, and I know a lot of it is also cloud focused, but we got to also remember a lot of organizations still have mainframes and they have, still their own, servers. And I know some of the companies still run, bare metal. And and you still need to be able to manage all of that, especially for the mesh, because mesh is all about connecting things, different things together. So therefore, it's by design complex. And therefore, our job is to make it easy and make it less complex so that people who we serve, because that's our job to serve our customers and make their lives better, so they can actually do other things, more useful things with their time, right? Instead of clicking around, maybe they can focus on creating or innovate in their space and let the tooling do the heavy lifting.
Yeah, definitely. Well, I have one more question, or actually it's two questions, and you can pick which one you want to answer. Do you have an example of a customer, a company that's done this really well, or do you have an example of a customer who had their Kafka-based system really go off the rails and end up in a firefighting exercise? And so, what does either of those extremes look like in your experience?
I mean, I think what happens is in many situations, you have kind of this vision of what the world should look like, right? But what happens for many organizations, they start somewhere and they start, okay, we're going to start with modern observability. Now, what I see more and more is this focus on automation. So for example, especially with Kafka and deploy and the release cycles of applications, where they tie the observability metrics into CI/CD pipelines or vice versa. So for example, you roll out an application, part of the rollout, you got to automate a bunch of infrastructure pieces. And it's not just containers, now you've got to deploy topics. So, and one of the ways that we've enabled this is through a set of different APIs and RESTful calls where as part of the CI/CD pipeline, you now trigger a set of automations that go out and deploy a bunch of things in this environment. So that's part of an example of an automation. The other part is obviously dealing with anomaly detection, where you observe certain things and you say, hey, there's going to be a problem, or there's a latency or the traffic problem. Well, why don't we provision more resources? Whether that's partitions or maybe allocating a few more topics and things like that. So again, there are ways that you could do this. However, a lot of the organizations move slowly, so they deploy maybe one part of the solution and then they deploy another part of the solution. It's part of the kind of, I would say, a maturity cycle of organization. And then there are situations where I've seen customers where let's say messages get stuck, and I mentioned it as an example of that. And now let's imagine you're a bank or a financial institution, and the message is not just some query, but let's say it's $100 million payment that is stuck. Well, now knowing that it's stuck is half of the problem. I would say 30% of the problem. Well, now you got to do something about it. So one of the ways we do what we focus on with the capability is called message management, where you can actually take messages off certain topics or queues and then move them onto an alternative route. And that means problem mitigation. And that could turn a hairy problem for some organizations into a simpler, right? Versus, especially when we're dealing with like financial, that could be a penalty right there. That could be suddenly an SLA violation, and you could be penalized because you haven't reported properly or you've not processed a payment appropriately. But in this case, we are allowing that traffic to continue because we provide the tools to mitigate that. So that's a couple of ways that I just mentioned of how organizations can use the tooling. One is automating deployments and automating workloads. And the other is mitigation, especially when it's like, okay, we got a problem now. We got a P1, Sev1 problem. We got to do something about this, and we provide the tools to deal with that.
That's interesting. An alternative routing type of scenario that exists in your software there. I mean, that's I hadn't really seen a function like that too much in the wild. So it's very interesting to see that you have this ability to kind of, if you had an SRE, or even if you don't, you want to be able to get some alert that, hey, something is stuck or something is wrong, or you also have the negative scenario for that too, like for security reasons, or say fraud detection, or things like if a thing is going through that shouldn't go through.
Exactly.
You want to be alerted of that as well, right?
Yes, and then I know it's a whole topic, and we probably should have a discussion just on that itself. Meaning, what does it mean actually to track things? And part of that is really not just like you said, okay, here's the normal way of how things should be moving, and here's an abnormal. And then abnormality could be not necessarily just performance. It could be a security. Like, for example, traffic is being rerouted through an abnormal pathway. And one of the reasons could be you have an internal breach and somebody siphoning off traffic for some other reason. And somebody in the organization should be aware of that. Because today, that could be a reputational damage to the organization that would be very difficult to mitigate, right? If somebody says, hey, somebody's stealing your payment information, your customer information, you didn't know about this for 6 months, and now it's out there in the public, and your stock price is crashing, and your reputation is in the gutter. I mean, you shouldn't be in that situation, right? You should have enough observability and enough tooling to be able to know when this is happening.
Yeah, definitely. That is really a big part of it. It's just situational awareness to what's happening in real time. That's what it's all about.
Correct.
Well, great, Albert. This has been a really fun discussion.
Same here.
And Jess, take us away. Do you have some resources that our viewers can look at?
Yes, so thank you, Jason and Albert, for your insightful presentation, and thank you everyone who joined in today. We will have this Tech Talk available on demand, posted on the meshIQ website following this call at www.meshiq.com. And as a reminder, we have more Tech Talks coming on different middleware technologies, and we would love to have you join us again. So please be on the lookout for our future webinars. There are QR codes on the screen if you want to access those past Tech Talks on demand, or follow our LinkedIn and Twitter. If you have any questions, you can email us at marketing@meshiq.com. And so thank you again, and have a great rest of your day, everyone.